Hello and welcome to this build video, soldering video for the Gris, the Gris throughhole reversion. So basically what you need is a PCB set, which you can either buy in my shop or order yourself a 5-pack from JLC PCB or any other PCB manufacturing service. The project is open source, of course, building on Emily Gillet's design. So you need a set of PCBs. You need the components. If you buy the components from me, you get something like this, and you need a Arduino Nano. So it's an 18 mega 328 development board. You can get these on AliExpress or eBay or any of those places. Cost a couple of bucks. I might have a few in my shop together with this, because I bought a few, because some people don't like to put software, firmware stuff on these. It's too complicated for some people, or they can't be bothered. So therefore I have some of these preloaded with the firmware. If you don't do that, you have to buy this and put that on there. Yeah, I'll discuss that in another video, I believe. A copy of the schematics is always good to have. That way you know where to put the components. There are only the designators, not the values. So a copy of the schematics is really good. You can also, nowadays, because of a really good plugin into ECDA, I also have IBOM files, so you can, if you have a computer, you can follow along and just press the different components and see exactly where on the PCB they belong. Other than that, you need pliers and a soldering iron. That should get you there good enough. Some solder paste, of course, and I like to have a soldering suction thing so I don't get this solder fumes in my lungs. In this case, I just have a PC fan just standing on the desk. Works really nice, and a helping hand is always good when things get crammed. So let's split up the things here. We put that to the side. So I usually like to start with the resistors and the IC holders. All these here we have some capacitors, some LEDs we wait with, all the things that should be on the front panel. We move out of the way for now. Depending on what you buy, this is one of those things. These are the MCP6002. They are SMD chips, and then you get these extra converters that converts or adapters that converts the SMD to throughhole, and then one of these as well. So you get one of these, so you get to get these onto the PCB. There is a price change. I'll see if I can find these in the normal dip package that actually fits in these, but they are almost twice as expensive, so there is that cost factor as well. But we leave that for now as well. So let's mount this here, and we want this side. So this is a one PCB design. I've crammed everything in here, and let's see if that works. Good enough. So this is basically here we have 26 100K resistors. So the majority of all the resistors are 100K, and then there's a bunch of 1K, and then there's actually only 5 other resistors with other values. So there's the chance of getting it right, putting a 100K resistor, is high. So let's start. R1. And this is where the I-bone would be really nice. So R1, R2, R3, R8, R7, R6, 11, 12, 13. So I'm just gonna start adding them here. That was 11. And I'm gonna cross these out. We had 8. And 7 is also down here in this corner. And we had our 1, 2, 3 is up here. 1, 2. And 3. And 1, 2, 3. And we said 8, 7, 6, and 11, 12, 13. They're down here. Let's just begin to add these, and we add some noise by starting the fan, of course. really need to fix this. Really wobbly in my helping hand here. Not very helping at the moment. Oh, that was really bad. There we go. Let's snip these off. Right. So, gotta fix this one. Oh. Tea is also nice to have when you do this. Although I just squimped my on the table here. So, let's continue with the 100K. R4, R5, and R10. R5, R4. So we have R4 is there. R5 is there, and R10 should be in this. Yeah, there we have it. So we have this section here, and there, goes up here, here, and here. Kind of similar, not exactly, but kind of. Then we have 16, 17, 15, 16, 17, 19. Then we have 15. Right, so they're up here. 16, 15, 15, 16, 17, 19. So they're all in a row here. Very nice. And 19. These are basically 6 identical circuits, so that's why there's so many of the 100K. So here we have 22, 23, 20, 21, 22, 23, 24, 21. Here we have it. And then going down, 22. A little bit to the left, 23. And up 24. Let's solder these. downside of cramming this much into one board is does get a bit crammed from time to time. And I believe that was all. Snip these off. Right. We have 6 left then. So we didn't do those. We have 26, 27, 28, 29. So 27 was there. Here's 27. '28 is down here. It's a bit off. '27, '28, '29 there, and 26 just there. 29, 26. Then we have 2 more down here on the clock input and reset input, so R21 and R26, R31 and 36, sorry, R31 and 36, there's 36, and there is 31. Trying to solder, getting in a tight space and at the same time not blocking the camera. That is a challenge. Right, so we can move on to the 1K. Actually, let's do the 1 meg because those are down here. We should be able to find them quite simply. We were just here, R31, so R32 is 1M, that's up there. And R35 right there is also 1 meg. So that's 1 meg out of the way. And down there we also have some 10K. Should we take those? Let's take the 10K as well. R33. There, and I would guess it's R49. No, it's not. R34. R34, there it is. So 10K, R33 and R34. Den är alltid, jag känner den. Stryker ju ändå. We have a stray cat in the neighborhood, wreaking havoc amongst the cat population. And my daughter had seen it on her walk. So there's actually another 10K resistor somewhere. Let's see if we can find it. Nope, we just leave that 10K resistor for now. We will find that later. Or we use the I-bomb. Again, can really recommend using that. So now we have all the on the schematics. Over here we have all the trigger outputs. Are 1K, so 38, 39, 40, 41, 42, 43, 38. It's up here. $39, $40. We have $40 there. $39 is down there. $41 and $43. $38, $39, $40, $41, $42, $43. There should be one more. 42. I didn't take 42. I missed that. There. And then 4 more, and those are up here for the LEDs. I think 1K is good for those. That might change. This is the first revision, but that's 47 right there. 48. 47, 48, 46, and 49, so that's 49. No. Alright, so I believe there are a few on this side. Yes. So there's a few LEDs on the other side. 2 of them, I believe. So let's just add these here first. Come on. Right, so there, alright. I'll clip away the legs again. So on this side there are actually 2 resistors, 48 and 46. So that's 48 and 48 and 46. Yeah, so there's 2 of the resistors for the LEDs is on this side. Let's have some tea. Right. So then we have some capacitors. Wait, R44. Let's find R44. I'm guessing that's the missing 10K resistor. There we have it, down in the negative 5 volt reference. R44 is of course the last 10K resistor. So add that as well. And now that's really crooked. Now we can move on to the capacitors. We have 10 nano, 100 nano, and one other something rather. And two diodes we also pack together with this. And also we have two electrolytic capacitors. These are either 100 or 22 or something in between. It's not that important, it's just to keep a stable voltage, or enough power for it, so it won't lose power and be glitchy and stuff like that. I think in all these we have 10 nano, 10 nano, 10 nano, 10 nano, 10 nano, 10 nano. That's a 10 nano farad capacitors, which I have here. So this one is a bit different, so we just bend one of the legs over so it's standing like so. C1, C2, C3, C4, C5 and C6. So there's C4. There's C1. Gonna add a note to make the solder pads bigger. This is not the final production module quite yet. There's C6. Because these small things are super hard to solder. C5. See here it should be 5, right? Here I've made the solder pads much bigger and better. But now I'm uncertain if that is a 5. There's C3 anyway. One, 4, 3, 2. There's C2. Yeah, that's number 5. C5, fix, silk screen. can attach one leg on this side, makes it easier. Otherwise these have a tendency to creep out when you turn them over. And with the bigger solder pads it's really nice. This one is a small one. Actually works today, it doesn't work every day. Snip these off. That's that. Let's next in height, or yeah, we can put the diodes, we can put those on. So we have two different kinds of diodes. One D4101, which is just black with a white line. That's has to do with power over here. D1, so that's D1. And then we have a Zener diode also that has to do with power, but that is to limit the voltage to 5 volts in the -5 reference. So that's D2, of course, that's the only other one. On the silk screen there is, I should say that, there is a small square, and then there's an even smaller square in one side, and that corresponds to, in the case of the black diode I have here, there's a silvery line. You align that silvery line with the small extra line on the silk screen, and on the red one there's a black line, and you align the black line with the extra line on the silk screen, silk mask there. And snip these off. Before we add a little bit taller components here, I like to add the IC sockets, because it's always nice to have them, because then you can just move it over, take this, squeeze it and flip it over to keep them in place. On the silk screen again you have an indentation in one of the edges of the IC. So on U5 you have it up there. You have that same indentation on the socket, so you just align the indentation on both. Same here on U1, there's a small indentation, you should see that. Align that up with there. U3 and U2 down there. Not the band, just a little IC. And then we do it like this. We just squeeze those together and we turn over. And this should now be nice and flat, and hold these in place so we can solder them in place. all there. Just the rest of the pins. That one done. Here. Come on. All right. So we continue with more capacitors. We have 100 nanofarads. Usually has to do with power. We have that down here. C7, 8, 9, 10. Just gonna rip these off. So these are markings 104, which means 100 nanofarad. What did we say? 7 to 11. 7, 11. Funny. 7 we have there. 8. So they should all be in close proximity to these ICs. That's 9. 10. And 16, that's not it. 11, there we have it. Should we now guess that C16 is this one? 470 nanofarad. So it's the only one we have left. C16, I saw it there. So tight squeeze in there. So I'm gonna, because this one stands out a bit more than the other ones, gonna do that, and then I'm gonna bend it down a bit, and then we can flip this over . gonna snap these off. Right. So I have a few things hiding under here. Right, I want to add this one, the power connector, before I add these, because these are taller. So again, just to get a nice fit. So again, there's a hole in the plastic shielding around, and that corresponds to this little extra square on the image. So you line those up like so. So the hole is facing away from the PCB, and we solder that in place. Let's add the transistors. That is Q1 and Q2. Down here is 1. And the other one is down there. So you just align the shape of the transistor to the shape on the PCB, of course. And we can solder these from the top or from the bottom. I'm gonna do the bottom. And the final two components, depending on how that doesn't have to do with the front panel or the Arduino. So these have a white marking on one side, and where the white marking is there is also a much shorter leg that aligns with the white marking of on the PCB. So you see on C14 and C17 there's an extra white marking there. On the other one there's a plus sign, which is of course the other leg. So the longer leg in the plus sign side, and then you just put the other one there, and here we have the white line and white line. Line those up. Like so. And we solder this. Totally botched that. Have to fix that soon. So this one is completely soldered together. If that happens, you can start by just moving the soldering iron over the area, and if that doesn't work, I usually do this. I heat it up and then I bang it into the table, and usually, as in this case, it takes away a bit of the solder, which makes it a bit easier to fix it. Didn't help in this case enough, so let's do it again. So we heat it up. Still a bit. Come on. There's a tiny bit. I don't think there's a connection, but right now it just bugs me. Bring in the magnifying glass. That's fine. Not beautiful, but fine. Always good to have the multimeter. I'll get that later. No, I'll get that now. And most multimeters should have a continuity checker or diode checker, so usually you turn it on and you do like this and it beeps. So these two should not beep. There was a small beep, but that's because it's a capacitor, so it fills up with current and then stops. Yeah, totally fine. Right, so these, can we add these later? I would say let's not add that later. That will be really difficult. So we really need to add these now. And it's always good to line these up correctly. I like to take this one out of the bag as well. So we solder all this together at once. And it should be like this. The USB port is facing downward. Right. Yes, the USB port is facing towards the edge like that. Doesn't show that. USB port on sync. So we have to add that. So that will be easier to know that is how it's supposed to be. So now what we do is we just solder everything in place, and let's make sure we do it correctly there. So just adding a few here to make it rigid. And then we're gonna add everyone else. What? Oh. My soldering iron turned off. It was set for 1 hour. So we are on 1 hour. Come on. Right, so now we know it lines up. Now we just need to solder it to this one. And never, like now I've added the 4 corners, and now it should be quite straight. Yeah. Never think that, oh, now is a good time to remove this, the nano. That is not a good time. That will rip some of the pins out. I've done that one time and it was a complete mess. Cannot recommend doing that. That is all the components as such. That doesn't have to do with the front panel. So now let's bring this back in, and this is quite straightforward. This side, like so, we have potentiometers, 7 of them. You just line them up and press them in. They should fit quite snugly in place. These are quite good because they don't fall out, so you can put these in and then move about with the jacks afterwards. The jacks is a bit more difficult. In this case, I don't have thonkiconn jacks because I am all out of thonkiconn jacks. These are a cheaper model that has these solder lugs instead. I use these in my ASMR, and there I showed that you need to add a small piece of one of the legs that you've cut off. You need to add between the solder lug and the PCB. So a bit more work, but they are also a bit cheaper, if that is a factor. I'll try to find thonkiconns for the component sets. Otherwise, if you have your own, I'll sell them without jacks, so you can use your own. Buying from Thonk, for example, does add so much cost that I have to ship them here and then ship them from here with import duties and stuff like that, so it's a bit, it's unnecessary money. That's what it is. To add, it's a bit tight here. Let's see. So here we have, these actually share the same pin, and when you have thonkiconns, that's not a problem. When you have these, it's not a problem, but you need to bend these a bit. Like so, and then you put it in, and then you can put a piece of wire in between both of these. And into the PCB like so. I'm just gonna add some solder here, it's easier. When it's not as crammed as it gets. Again, this is an overly complicated step if you have thonkiconns, which I just have to do because I'm out. And the final one. And before we do anything else, we need to put this on and make sure we can align everything. Of course, these that we solder together might pose a bit of a problem. There is a lot of jacks and pots that needs to align, so it does make it a bit complicated. I, as usual, make it extra complicated by not removing these legs standing up here. See, I tell you, not having thonkiconns really makes your life much more difficult. Thonkiconn, the sponsor of this video. No, they're not. I'm just kidding. So we're not done here. We need to, once we get these in, we need to take it off again, because we actually have the LEDs and the button as well. But adding them at the same time just makes it even more difficult. There. See, now we have that in place. Everything looks and feels as it should. I choose to add a few of these just to hold it in place. So one there, one here, and let's add one up here as well. And because the potentiometers is so nice and flush, they should keep everything else in place. Right. So, time to solder again. All these potentiometers and jacks. Almost done, and here's another one. That one, and then we have all the jacks down there. This one as well. here we can add the legs for the ground that we added down here. My soldering iron is not the best one, so it does have a bit of problem heating up the huge soldering, the huge ground copper plate that is in this. Yep, I believe that was it. So now I need to add all these legs for the... I just picked some of those up. Put them all on the floor. This is again a very unnecessary step with the correct, well, with the much easier thonkiconns. This probably adds like 20 minutes to the build. And remember to take these off. Same on this side, or else we will have that same problem again, that we can't get the panel on because of these sticks sticking up. So the final things that needs to be aligned is the LEDs. I chose green. It should be, you can choose whatever color you like. These are usually, there's one side that there's a ledge on the LED that you can feel with your fingernail, except on one side where it's faced off, and that's usually the side with a shorter leg. And that is on you. If you look on the PCB, there's also a ledge, or the circle of the LED is cut off, and that is where the short leg goes. So in this case, the short leg, it goes downwards from looking like this, and here we have the same short leg downwards, and there downwards like so. And the final component is this button and LED in one. This one has, if you look on the underside, it has one side has two small protruding plastic things, and the other one has one standing on a small pedestal. Like there's a small square, and then there's that extra pin standing up on that, and depending on how you look at it, that pin is sticking up much more than the other two and everything else. So there's one plastic pin sticking up. That corresponds, if you look at the on the PCB, there is one extra hole actually in the PCB of the button. So on this side, on the top, there's an extra hole in the middle, and that one should align with that hole. If you do that, it will stand very straight, very firmly like that. If you place it the other way around, it will stand very crooked, and that will actually make it not work, because it will push, this will push against the front panel, and it will be pushed in all the time, and that will just be a lot of trouble. So that small plastic pin in the small hole, and it should stand very nice and firm like that. I have added on the back side, this is the, if you want, you can take a picture of this or just read the manual, RTFM, of the Gris or grids. So what this is just that if you press tap and hold it for 1 second, you will get into a configuration menu which has these things on it. And just want you to know that, because there are some quite nifty little things there as well. So let's try to align this again. Should be, if we aligned it well enough last time, it should be easy this time. Make sure the button works. You press hard, and here it is working, so now you know it is correct. The LEDs, so again I'm actually going to add the washers as well. Just add these 3 again, so we don't need to remove them again if we've done everything correct. one was working. These ones we should turn around and make sure we get them in place like so, and make sure they stay there. Press down firmly and we solder these in place. So we need to fix the solder pads on the LEDs as well. Because once they become like this, it's super hard to get them to stick. Like this one here, right here. I can just keep on adding solder there. I could also get a better soldering iron, which I say in every soldering video I make. And then we have the button again, make sure it works, standing straight and nice. And it still works good. Then we can add all the other pins. Right, so that should be it. If you bought with knobs, now is the time to put the knobs on, I guess. Maybe not, we need to add the last few nuts and also make sure that we don't have any shorts. I've actually added a test. I have to move the test area to the other side, I see, so it's on that side, but over up here is a test area, so we can, the middle one is ground, and from this side the left one is 5 volts and the other one is minus 5 volts. Change side test. So we can just plug this in and make sure we don't have any shorts. Once we know that, we can add the components, this one and the, right, we have these as well. So I've done a video showing how to solder SMD quite simply. It's not that hard, but it's, I don't know, I like to have this form factor here, because then you, if you mess up, you don't mess up the whole board, you just mess up this tiny board and you just add another one. So always interesting to see which is number, which is first pin. Is it phased? Let's say no. There's no dot. There's a line. I would say, because the line is there, that is number 1. So that should be, let's making sure, so this should be pin 1 and that's not that one. That's pin, oh, that's pin 1, and of course it is, because we do like so. Yes. So what I like to do, I like to take, to begin with 1 pin, just add some solder like so. And take a tweezers. So in this case we do need one more tool, a small tweezer. Just hold it where I want it to be and just heat that one leg. And there it is in place. And then we just add some solder to the other pins. Just making sure that I actually touch the pin of the component, and I just drag, oh look, messed that up. We can fix that, no problem. Needs so little solder. That one is totally fine. I messed that one up. Usually you can just do that where you just pull, or you just heat it up, do that. Yeah, I have that one up, I think. There's some left there that I can't get away. Can't get it heated up because I can't get in there. I think I got it there. Yep. Got it. Yep. So that one's good. So solder on one pad, line it up as we want it. Mess up, just lift it up, start again. First one was much easier. There we go. I'm happy with that. So there is a bunch of extra stuff in this video that you really don't need if you just have the correct components, but sometimes life throws you lemons. And in these days of the shipocalypse, we should all be happy with what we can get, I guess. Yeah, that works. There. Oops. So let's add some headers to this. Can always be a good idea to put it in place when adding the legs, so you know it will align. This one we can just add. That's the 595 74 HCLC 595. That way. Boop, boop, boop. 1, 2, 3, 4. 1, 2, 3, 4. So you can either just use your nail or a clipper to get those off. And then of course the final step, we need to flash this one with the firmware, which I'll show in a different video if you haven't already done that. And we place that in there, and we should now be done. Yeah, so this was the soldering video for the Gris throughhole grids module. There are loads of tutorials on how to use the grids. They work for this one as well. This one is actually using the exact same firmware as the original version. It's just using through-hole components instead of the surface mount components used in the original. That's the only difference. And that you made this one yourself, of course. So, hope you like this video. If you want more like this, you know to subscribe to my channel, where I do a bunch of this stuff all the time. So, see you in the next video. Take care. Bye. Oh, come on. All of these. These knurled nuts, I really don't like them. Much nicer with the hex nuts.